Okay, so today we're going to continue with our discussion of parts of circles and include arcs and chords. Points on a circle determine both arcs and chords. Several properties are related to the points on a circle. So if you've got a circle or congruent circles, if two minor arcs are congruent, they are if and only if their corresponding chords are congruent. So what that's saying is, if RS right here, I'm going to highlight it or whatever, it's not quite a highlighter, but if RS is congruent to TV, this is in our ISN, that is, if that's true, it's true if and only if those chords were also congruent. So this chord would have to be congruent to this chord, the ones that they're made by, okay? The endpoints of the chord are the same as the endpoints of the arc. So if we've got the circle with center K and arc AD, this is a typo. I can see that right away because I don't know how we didn't catch this before we printed it. It should be arc AB. Please change that D to a B. So if arc AB is congruent to arc CD, then that would mean that the chords are congruent. So segment CD is congruent to segment AB, so we can set it up. 8x equals 2x plus 3. We would do our algebra magic and subtract 2x from both sides. We get 6 times x equals 3. And divide by 6. Be careful, you're not doing 6 divided by 3, you're doing 3 divided by 6. And you can write your answer as 1/2 or 0.5. Okay. And then it says to find AB. So I've got x is 1/2 and it says find AB. So AB would equal 8 times 0.5, which is 4. All right. The next one says find the value of x in each circle. We need to remember that a central angle is equal to its arc measure. So this measurement is equal to the measure of the arc. This is 1/16, and it shows that the chords are equal here and here. So if those chords are equal, then those arcs are equal. Therefore, you can put 1/16 over here. And that angle x is the same as that measurement, so x is 1/16. Okay, the measure of an arc is equal to the measure of its corresponding central angle. Okay, on the third one here, we've got 64. We've got those chords are congruent. If those chords are congruent, then the two arcs ST and SR are also congruent to one another. So those are equal. If I have an X over here on arc SR, I can put an X over here on arc ST. So now what do you think all the arcs add up to? If it's in degrees, what would they all add up to? Yeah, 360. So we got x plus 64 equals 360. That's our equation. Combine your like terms. Subtract 64 from both sides. We've got 2 times x is equal to 296. Right? Divide by 2. And x is 148. Is that 48? Thank you. Degrees. Okay, the next topic is about a different relationship with chords and diameters. In a circle, if a diameter or radius is perpendicular to a chord, so if you ever see a diameter or radius perpendicular to a chord, which means forms a right angle, you should know that by now. We've only used the word perpendicular since the first couple of weeks of school. And it's now April. So forms a right angle. So if you see that, then that chord got cut in half. It bisects the chord and its arc. Bisect means cut in half. Should know that word as well. All right, so in this diagram, WZ is perpendicular to AB. Therefore, AX is congruent to XB, and the arcs WAW and WB are also congruent. That's what it's telling you. In a circle, the perpendicular bisector of a chord is the diameter or radius. So if you see there's a perpendicular segment, you know that this piece coming from the center is definitely a radius. Right now, according to what we just said, we would also have some congruence down here as well, because OZ is perpendicular to RS. I'm not going to assume anything at this point about whether it's equal to all the stuff up there, but based on what it's saying on this next picture, we're going to find out that it is. It says in a circle or in congruent circles, two chords are congruent if and only if they are an equal distance from the center. Okay, so in this picture, if OX is congruent to OY, then we know that chords AB and RS are congruent. Okay, so that tells me that this chord is congruent to this chord. And if AB is congruent to RS, then RS has to be equidistant from the point O. So that's just the converse of what this said. All right, next. I think we're just a few examples of what to do to use this. Oh boy, I see some little right triangles. Guess what's coming? Pythagorean theorem. You got a circle with center O. It says that CD and OE are perpendicular, forming a right angle. OD is 15, so I'm going to label that on my diagram. C to D is 24, and what do we know that OE does to CD? Okay, so think about that for a second. What has OE done to the segment CD? Bisected it, okay, because it's at a right angle, so it's bisected. So if C to D is 24, how big is it from C to E and E to D? They're each going to be 12. All right, so 24 divided by 2 is 12, so I know that this is 12 from C to E, and E to D is also 12. All right, right again, a radius is perpendicular to a chord, bisects the chord. That's what I just used. So ED is half of CD, and that's where we got the 12. Use the Pythagorean theorem to find OE. So I'm going to put an X on OE, and I'm going to say OE is a leg, ED is a leg, and OD is the hypotenuse. So x squared plus 12 squared equals 15 squared. We've been doing this Pythagorean theorem since the first week of school as well. We're going to subtract 12 squared and 15 squared. So I noticed that on this recent test, which those grades you'll be able to see in Skyward later today, that some people are doing this Pythagorean theorem incorrectly. They are adding 144 and 225 right now. What's wrong? We need to subtract it, okay? So we need to do 225 minus 144, which is 81, and then we take the square root. So if x is equal to the square root of 81, it is going to be 9. All right, so I found OE is 9. All right, so another example. I got the circle with center P. It has a radius of 13. So if I know that, then if the radius is 13, QP is 13 because it's the radius. I'm going to jot that down. QP is 13. I got R to S is 24, but that QP is perpendicular to it, so it cut it in half, which means RT is half of 24, 12. Okay, so I'm going to put 12 right here on RT, and this would be 12 as well. Okay, now it says, I want to find P to T. Well, that's this tiny little piece right here. I wish I made this circle a little bit bigger. It says to draw in radius RP. Well, then I'm going to draw from R to P a segment, and I'm going to label it 13 because the radii of this circle are 13. I need to find P to P, so I'm going to put an X by that. Now, if that looks a little too tiny to you, I'll just draw it a little bigger. R, T at the top. P would be down at the bottom here. I have an X on the T to P. I have a 12 on the R to T. And I have a 13 on RP because it's the radius. We got a little baby right triangle here. That would be a right angle. Okay, so I'm going to do Pythagorean theorem. So to figure out what P to T is, I'm going to do x squared because that's a leg. 12 is a leg, so x squared plus 12 squared equals the hypotenuse, which is 13 squared. Okay, so that would be our Pythagorean theorem filled in. Now we're going to do x squared plus 144 equals 169. Subtract 144 from both sides. X squared equals 25. Take the square root of 25 and find out that P to T is 5. All right, so P to T is 5. Now it says to find P to Q. Well, Q to P we wrote down is 13. P to P we just found out is 5. So what's Q to T? If Q to P is 13 and P to P is 5, what's left for Q to T? Well, it would be 13 minus 5, so it's 8. Hope we understood where I got 8. Questions about where I found the 8? Oh, all right, that is the end of the ISN. Let's try some more problems in the packet. If you would like to highlight again the properties we were just discussing, I will do that on this circle. I think I'll actually grab a highlighter. Okay, so if I've got arc RS, it's just reiterating some things we wrote in the ISN. And I've got arc TV. Those arcs are congruent if and only if segment RS is congruent to segment TV. Okay, so these are congruent if and only if the chords are congruent. Okay, that's it. And using that, if we see congruent chords, like this chord's congruent to this chord, those arcs are congruent. My brain's going away from me. These would be these chords would be congruent to one another because the arcs are. All right, there we go. 2x plus 4, we're going to set it up, equals 18, an equation to solve for x. Subtract 4, we got 2 times x is 14. Divide by 2, and we get x is 7. Calculator die. All right, number 2. That should be a really fast question. These are equal, therefore the arcs are congruent, and so x is 82. Number 3, the chords are congruent. So these arcs are congruent, which means I can put an x up here. And then I say, well, all the arcs would add up to 360. So I've got x plus 90 equals 360. I simplify. I subtract 90. I get 270. And then I divide by 2, and my answer will be half of 270. X is 135 degrees. Okay, number 4. Find the value of x again. Since the arcs are congruent, then the chords are congruent. So let's do 5x minus 5 is equal to 2x plus 1. Subtract 2 times x. 3 times x minus 5 equals 1. Add 5 to both sides. 3 times x is 6. Dividing both sides by 3, we get x is 2. Okay. Number 5, we got circle M and circle Q are congruent. If they're congruent, then the chords, since their arcs are congruent, the chords are congruent. So 6x is equal to 2x plus 24. Subtract 2x from both sides. I got 4 times x equals 24. Divide by 4, x is 6. And these seem to be pretty easy so far. Number 6, this one's a little off. What do I need to figure out? Some of you going ahead of me. I'm just wondering because I've seen people just working and... All right. What did you do for 6 if you're on 6? What's the first thing I need to figure out? These numbers don't match. What arc is this corresponding to in the second one? Is it here or is it over here? Is it where the 198 is? Oh, it's not. So we want to see what this is. So what do I got to do first? I got to figure out this length. I mean, not length, but its measure. How do I get it? Okay, yeah, I need to do 360 minus 198, guys. Okay, is it 162? That's good because now, if that arc is congruent to that arc, then these chords are congruent because the circles are congruent. So I got 9x minus 78 equals 3x. Okay, we had to have a reason that we can say they're congruent. So I'm going to subtract 9x from both sides. Here's another place we make some algebra mistakes. Bring down the negative 78. 3x minus 9x is negative 6x. Now we need to divide by negative 6. Okay, so we should have x is 13. Okay? Number 7. Now we're getting to that diameters and chords thing again. In a circle, if the diameter or radius is perpendicular to a chord, it bisects the chord and its arc. All right, so what we already looked at was that if this is perpendicular, then A to X equals X to B, and arc AW equals arc WB. So There's another part to it that it said in a circle, if the perpendicular bisector of a chord is the perpendicular bisector of a chord is a diameter or a radius. And if OX is congruent to OY, then the chords must be equal to one another. These would be equal. Right, which means this segment would equal this segment, and this segment would equal this segment. And it would also mean that those arcs out there are equal. Okay, so let's get to some concrete examples. That's just another statement. That's the converse. Let's get to 7, 8, 9. Ready? I didn't skip anything you needed, right? Okay. Circle with center P. It tells me the radius is 13. Is there a segment in this picture that is a radius? Is there a segment in this picture that's a radius? Oopsie, this is 25, isn't it? And this is 48? Thank you. Before I continued, that's good for me to fix that. Okay, now, is there a radius in the picture? That's what I was trying to get at. All right, QP. All right, so I'm going to jot down that Q to P is 25. Okay, we'll need to know that for finding T to Q. If you want to know T to Q, it's going to be QP minus TP. Okay, QP minus TP. So I'm probably going to have to figure out TP. And that's this right here. All right, so here we go. You've got RS is 48. So how big is RT? The half of 48. Yep. 48 divided by 2 is how we're getting it. Not in my back. My pen is stuck, so just a moment. What's going on here? All right, here we go. 48 divided by 2, and so it's 24. And I'm going to label that above it on the diagram. I would like to find PT. So I'm going to put an X there. I need to draw RP. Draw a segment RP. Now, what is RP? It's a radius because it goes from a point on the circle to the center. So it would be the length of the radius, which is 25. Okay, now I need to do the Pythagorean theorem to find the length of TP, which I labeled X. So that's going to be X squared plus 24 squared equals the longest side, 25 squared. 24 squared is 576. 25 squared is 625. We need to subtract. I got X squared equals 49. X is going to be the square root of 49, which is 7. So PT is 7. All right, now I want to find P to Q. Okay, I know that the whole radius is 25, so I'm going to do 25 minus what I found for TP, which was 7, and TQ is going to be 18. All right, try another. Got a circle with center point A. Diameter is 12. Oh, it says diameter is 12. If the diameter is 12, what's the radius? R is 6. Do you want to drop that? I would jot that down right away. The radius is 6. It says CD is 8. That's its whole length. Just got 3 minutes, so it's not 3:15 yet. Okay, CD is 8. So we know that right here bisects CD. So each of these would be 4. The measure of arc CD is 90. Okay, so what happened to the arc? That's 90 out there. How big are each of these arcs? We're going to do 90 divided by 2. So these are 45. Okay, then it says, find each measure, round to the nearest tenth. Well, we just found arc DE. It's 45. Said, what is FT? Well, we already found that. It's 4. Now it wants us to find A to F. Okay, so that's right here. So I'll put an X on it. And I'm going to need to draw in a radius. So I'm going to draw in AC. Okay, and that is a radius. And we said the radius is 6. Okay, so now we would do Pythagorean theorem. X squared plus 4 squared equals 6 squared. Okay, and then subtract 16. And we're going to set to go to the nearest hundredth, so we're just going to take the square root of 20. What that's about, if we're going to go to the hundredths, that's 2 decimal places. So it's 4.47. That's what you got, right? I just memorized it because I did it twice today. Okay, 4.47. And then didn't ask us for anything else, so we don't have to figure out. We could figure out what it is to F to E, but they didn't ask for it. Lexi, you better go. All right, you got, these are equal. Since those are equal and there's a right angle there, what does that mean? What does it mean? That what can we assume or tell if you've got an equal segment there and it's perpendicular to a segment over here, it's perpendicular. If these distances are the same, that was one of the things we just went over in our notes. It tells me that the chords are equal. That's what it tells you, right? We need to know that. When we see that in the picture, that's telling you that chord equals that chord. All right, now, TS is 21. UV is 3x. So these are, TS is equal to UV. So we're going to plug in. 21 equals 3x, excuse me. Divide by 3 and we get the answer. X is 7. All right, number 14. What does QE being perpendicular and QG being perpendicular here tell me? It says, let's see, the circle in center Q, it says up here that CD is congruent to CB. All right, it's telling me that. All right, now that would mean these have to be equal. Okay, so that tells me those have to be equal. Because they told me the chords are equal, now those have to be equal. PQ is x plus 5. I already know now that, PQ is equal to QE, or EQ, so I'm going to set them equal. All right, I'm going to subtract an x from both sides. I got 5 equals 2x minus 6. Next, I would add 6 to both sides and get 11 equals 2x. Divide by 2. I get 5.5. All right. Now you've got practice. I'm going to give you some time work. If you've already found one you need some help with, you can tell me. But please get going on your assignment. You've got quite a bit of time to get a bunch of this done.